Welcome, developers. Today, we are taking Claude Code to the next level by integrating it directly with your GitHub repositories. We will learn how to empower Claude to autonomously review pull requests, create branches, and fix issues simply by tagging it in a comment. Let's dive into GitHub integration mastery. Let's start by defining what the Claude GitHub integration actually is. What is it? It's a bridge that connects your repository's issue tracking and CI/CD pipelines directly to Claude's autonomous coding agent. The basics are simple. You install an app, and Claude starts living in your repository. Why is this a game changer? Because manually cloning branches, making small fixes, and pushing code for routine issues creates massive context switching overhead. This integration eliminates that bottleneck entirely. How do we achieve this? By installing the Claude GitHub app and configuring specific YAML workflows. In our deep dive, it is crucial to understand that Claude is not just dropping text snippets into comments. It is provisioning a secure compute environment inside GitHub Actions, analyzing your actual codebase, creating a dedicated working branch, implementing the fix, and opening a ready-to-merge pull request. It acts as a full, autonomous team member. Take a look at this flowchart, which maps the autonomous lifecycle of a GitHub issue. On the left, a GitHub issue is created. The moment a developer tags at Claude in the comments, the flow moves to the critical yellow node. GitHub Actions is triggered. From there, Claude takes over entirely. It analyzes the codebase, creates a branch to fix the code, and finally converges on the green node, opening a fully formatted pull request. You simply review and merge. Before we unleash Claude on our repositories, we must handle prerequisites and authentication. What is this? It's the critical setup phase where we securely link your GitHub identity with your Anthropic account. The absolute basics: you must have administrator access to the repository to configure these workflows and secrets. Why do we enforce this? Because security is paramount. Claude needs explicit, token-based authorization to read your private proprietary code, commit changes, and trigger CI/CD pipelines. How do we set this up? First, you ensure the GitHub CLI is installed on your local machine. Then, run the ghauth login command to authenticate your terminal. In our deep dive, understand that this process binds your GitHub identity to your Anthropic billing account. When Claude operates autonomously inside GitHub Actions, the tokens consumed are securely tracked and billed to your workspace, ensuring enterprise-grade auditability and cost management. This sequence diagram maps the strict authentication handshake. The developer runs the auth command in the terminal, which immediately reaches out to the GitHub OAuth server for device authorization. Once GitHub returns a success token, the developer initiates the Claude integration. The terminal then securely binds that GitHub token to the Anthropic system workspace. This guarantees that all autonomous agent actions are properly authenticated and billed to the correct entity. With authentication complete, we move to installing the Claude GitHub app. What does this mean? We are integrating the official Anthropic application into your repository so it can listen for events. The basics involve triggering the setup from your local Claude Code CLI, which handles the redirection to GitHub's web portal. Why is the app necessary? Because Claude needs webhook access to listen for specific triggers, like when someone comments on an issue or opens a pull request. How is it executed? You can simply run the /install GitHub app command in your Claude CLI. You'll be presented with two main capabilities: Tag Claude for resolving issues, and Claude Code Review for automated PR feedback. Our deep dive reveals that this establishes persistent webhook listeners. When you enable these features, GitHub begins routing issue comment and pull request payload events directly to Claude's infrastructure, waking the agent up exactly when it's needed. Here we see the installation flow. You run the installation command and immediately hit a decision node, select features. You can choose Tag Claude, which enables issue comment webhooks, or Code Review, which enables pull request webhooks. Both of these paths converge at the green node at the bottom, resulting in a fully active repository event listener that stands by, waiting for developer input to spring into action. To make this all work, we must configure GitHub Action workflows. What are these? They are standard YAML files that define the compute environment and execution steps for Claude. The basics are handled for you. The integration automatically creates an initial pull request in your repository containing files like claude.yml and claudecodereview.yml. Why do we use Actions? Because GitHub Actions provides secure, ephemeral virtual machines where Claude can safely clone your code, run its analysis, and generate fixes. How do you finalize it? You simply review the auto-generated PR and merge it. Look at the sample code on the slide. It defines the trigger event, the Ubuntu runner environment, and the environment variables. In our deep dive, notice the profound security architecture. No sensitive API keys are ever hard-coded. The system automatically provisions a GitHub secret for the OAuth token, meaning Claude executes with full context while keeping your credentials cryptographically isolated and secure. Examine this architectural diagram of the workflow execution. Inside the GitHub repository, our Claude.yml file provisions a standard Ubuntu GitHub Actions runner. Simultaneously, the secure GitHub secrets vault injects the encrypted OAuth token into that runner. This secure environment then communicates directly with the Claude AI agent, empowering it to analyze the code and push fixes back to your repository without ever exposing your keys to the public file system. Now we get to the magic, autonomous issue resolution in action. What is this capability? It allows you to trigger an end-to-end bug fix simply by using an mention in a GitHub issue. The basics: a user opens a bug report. You, the developer, simply comment at Claude, "Can you fix this?" and Claude takes over. Why is this revolutionary? It completely bridges the gap between issue triage and implementation. Senior engineers can instantly delegate routine tickets directly from the browser. How does it unfold? Claude reads the issue, spins up a GitHub action, creates a uniquely named branch like Claude/issue/123, writes the fix, and opens a pull request. In our deep dive, you'll see that Claude doesn't just guess. It generates an internal, dynamic to-do list. Crucially, its first step is almost always searching for a Claude.md file in your repository. It absorbs your architectural rules and formatting guidelines before writing a single line of code, ensuring the fix feels like it was written by your core team. This state diagram maps the lifecycle of an autonomous fix. We begin when an issue is opened. A developer moves the state forward by tagging Claude. The agent transitions into the Discover context state, actively seeking out your Claude.md file to learn your rules. It then moves into Generate Fix, modifying the codebase, and finally transitions into Open Pull Request, where it safely parks the new code on an isolated branch, awaiting human review. Beyond fixing bugs, we have automated pull request reviews. What is this? It's an asynchronous workflow where Claude acts as your primary, first-pass code reviewer. The basics: whenever a developer on your team submits a PR, Claude's review action automatically runs, deeply analyzing the Git diff. Why is this so valuable? It provides immediate feedback. It catches syntax errors, missing tests, and logic flaws instantly, saving your senior human reviewers from wasting time on obvious mistakes. How does it work? Using the Claude Code review.yml file, the agent parses the code and posts beautifully formatted markdown comments directly on the PR timeline. For our deep dive, Claude doesn't just look for generic errors, it evaluates the code against your specific constraints in your Claude.md file. If it finds security vulnerabilities, it requests changes. If the code is perfectly clean, it issues a formal approval, drastically accelerating your team's deployment cycle. Follow the review process in the sequence diagram. The developer opens a pull request on GitHub. This fires a webhook trigger to the Claude reviewer agent. Claude independently analyzes the Git diff against your project's rules. We then hit a conditional branch. If issues are found, Claude posts inline comments and formally requests changes. If the code is clean, Claude bypasses the feedback loop and immediately issues an approval, streamlining the merge process. Let's examine a critical real-time use case, the API contract hotfix. Scenario: a user opens an issue suggesting a simple variable rename from LinkedIn username to LinkedIn URL for better readability. The trap: a developer quickly tags at Claude, "Can you fix this?" Without deep project context, an AI will blindly rename that variable everywhere. The disaster: that variable was part of a payload sent to a third-party API that strictly required the key LinkedIn username. The code breaks. The solution lies in context engineering. The developer creates a Claude.md file explicitly documenting the external API contracts and retags Claude. The execution this time is flawless. Claude reads the issue, reads the context file, renames the variable for local readability, but intelligently maps it back to the required key in the API payload. The massive value here: Claude resolves the issue autonomously while honoring complex system dependencies, proving that true agentic coding requires engineered context. Look at the divergence in this flowchart. An issue requests a variable rename. We hit the critical decision diamond. Is Claude.md present? If no, the agent blindly renames the variable everywhere, leading to the red failure node: a broken external API contract. But if yes, the agent reads the API constraints. It renames the variable locally, but preserves the specific payload mapping, leading to the green success node, a perfectly safe hotfix PR. To conclude our mastery training, we must establish strict best practices and security protocols. First, always enforce human in the loop. Treat Claude like a brilliant junior developer. Never blindly merge an AI-generated PR without reviewing the diff yourself. Second, master your Claude.md file. As we saw, agentic workflows fail without context. You must maintain this file with your architectural rules and API contracts. Third, secure your secrets. Ensure your OAuth tokens are strictly scoped within GitHub secrets and never exposed in logs. Finally, actively review Claude's to-do lists in the Actions tab. If the agent misinterprets your prompt, cancel the workflow immediately and refine your instructions. Integrating Claude into GitHub transforms your repository into an active, self-healing ecosystem. I invite all learners to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep, including massive Q&A banks, full ebooks, audiobooks, full-length training, and expert interview guides. See you there. Our final mind map summarizes the pillars of integration mastery. We start with security, relying on strictly scoped OAuth tokens and GitHub secrets. We move to governance, highlighting the absolute necessity of human review and diff auditing. Next is context, where Claude.md stores your crucial API contracts and standards. Finally, we achieve automation, enabling seamless issue trio and PR reviews. Master these 4 pillars, and you master autonomous development.